Good morning students. So in this class we are going to discuss about momentum. So momentum is a vector. So the direction of vector is get from the direction of velocity. So the magnitude of momentum is a product of mass and velocity. So unit of momentum is kilogram meter second power minus 1. So in terms of components, so pxi plus pyj plus pzk is equal to mvx I cap plus mvy j cap plus mvz k cap. That mvx represents the momentum in x component, that is x direction, then mvy py, then mvz pz. So that is the momentum in y direction and z direction. So for example, butterfly and stone both come in the direction with on u with 5 meter per second velocity. So what is the impact? So stone hits more than the butterfly because stone has a mass greater than the butterfly. So stone has a greater momentum also. So the mass plays an important role in the momentum because momentum P is equal to mass into velocity. Then motion along one dimension. So for particle moving in one dimension means, so it's a vector. So it may be in positive x direction or in negative x direction. So consider in x direction a particle is moving. Then average velocity is a ratio of that position vector with respect to time. So here delta x by delta t, there is change in x, so x2 minus x1, t2 minus t1. Then what is the instantaneous velocity? So instantaneous velocity means at that instant what is the velocity. So that limit delta t tends to 0, delta x by delta t. So delta x by delta t, that is dx by dt. So the velocity can be found. So velocity, that is slope of the curve, that is between position vector and time, will get that velocity. So velocity equal to that is dy by, that is dr by dt, or it's a position, that is r represents a position. So in similar manner, if I give velocity and time, so how will find the distance and displacement? So just velocity equal to dx by dt, just rearrange. So v dt equal to dx, then integrate on both sides. So the dx from x1 to x2, then v dt from t1 to t2. So the displacement, so that is x1 to x2 dx equal to integral d1 to d2 v dt. So already we know the integration is area under the curve. So the area under the curve gives the distance or displacement. So here the right hand side, so the area under the curve v as a function of time. So this is the right hand side. So that area under the curve v as a function of time gives, that is the left hand side, that is integral x1 to x2, that is the displacement traveled by the particle in time t1 to t2. So this v versus time graph, so function. So from time t1 to t2, so that is area under the curve gives the distance or displacement. Then if the distance or displacement, if it is positive displacement, that area is in positive, that is positive displacement. If area is in negative direction, that is in negative displacement. So the area under the curve is present in, that is velocity versus time graph. That area is in positive side, that is positive displacement. If it is a negative area, that is negative displacement. So in this class we have discussed momentum, then motion along one dimension.